Okay, welcome to Chapter 1 of AP Physics. This is your first chapter, and we're going to take it kind of slow. We're just going to talk about sections 1 through 3 in this video. So, we're talking about Chapter 1, just sections 1 through 3 for now. So, Section 1 is really just about what is physics, and basically, physics is a science that studies situations and then makes predictions about what's going to happen in other situations based on what happened in one situation. So physics studies things like motion of objects, forces, energy, things like electricity and magnetism, how light behaves, all kinds of stuff. So we're going to get into all of that later, and here's just a couple of examples of where physics is used in the real world. Okay, so one skill that you're going to need in physics is how to convert between units. So first of all, this is very important. Every time you do a calculation, you should always write down the units explicitly. So if you're doing an equation where you have a speed and a distance, you want to include the units, and that'll help you to remember whether you need to convert. So if the units don't cancel out to what they need to be, then you need to convert so that they do cancel out or equal out to what they need to be. So treat all of the units as algebraic quantities. That means that if identical units get divided by each other, they get canceled out. So for instance, if you have 3 meters divided by 6 meters, your answer would just be 1/2, and the units would go away. So this would be a unitless number. Or if you have, say, 6 meters divided by 2 seconds, that would give you 3 meters per second, meters over second, or 3 meters per second. So if you include the units with your equation, with the numbers that you're putting in, it will automatically work out to give you the proper units that you need. So if you do need to convert units, there are some conversion factors in your book on the page that faces the inside cover. So when you're converting, we're going to use a conversion factor, or a conversion factor is basically just a fraction that is equal to 1. So for instance, we know that 1 inch is equal to 2.54 centimeters. So if we write that as a fraction, 1 inch divided by 2.54 centimeters, that's really equal to 1, because 1 inch and 2.54 centimeters are the same thing. That's like writing 5 divided by 5. It equals 1, because it's the same thing on the top and the bottom. So let's look at an example of how to do a unit conversion. So let's say we have a speed limit, 65 miles per hour, and we want to put this in terms of meters per second, because in physics we use SI units. So the SI base unit for distance is meter, and the SI base unit for time is seconds. So we know that there's 5,280 feet in 1 mile. If we didn't know that, we could look that up either in our book or online. We also know there's 3,600 seconds in 1 hour. Now, maybe you didn't know that, but you do know that there's 60 minutes in 1 hour. And we know that there's 60 seconds in 1 minute. So if we multiply those together, the minutes cancel out, and we get 3,600 seconds per 1 hour. Okay? And then there's also 3.281 feet is equal to 1 meter. So first we're going to try to get rid of the miles and the hours. So this is showing us that we're going to multiply this by 1 and then by 1 again, except we're using 1 in the form of 5,280 feet divided by 1 mile. So we don't have a 1 here, but we could. This is just saying 1 mile is equal to 5,280 feet. So this term here is actually equal to 1. So if we multiply our original number by this, it doesn't change the actual amount of our measurement. It's just going to change the units. So we see that the miles cancel out, and now we're in feet. We can also multiply by our time. We knew there's 3,600 seconds in 1 hour. So up here we wrote this as 3,600 seconds over 1 hour. But we could also write it as 1 hour over 3,600 seconds. It doesn't matter. Those are equal to each other, so we can put them in either order. The order you want to use for your problem is the order that's going to allow you to cancel out the units that you don't want to keep. So originally we had hours on the bottom of our fraction. So in our conversion factor, we want to put the hour on the top so that it's going to cancel with this one, leaving us with seconds on the bottom, which is what we want. So remember, we're ultimately trying to get meters on the top and seconds on the bottom. So we've got seconds on the bottom now. That's good. Now we just need to focus on getting this feet changed into meters. So right now we have 95 feet per second. So to summarize, we took our 65 miles per hour original measurement, multiplied that to change miles into feet, 5,280 feet per mile. So 65 got multiplied by 5,280. And then we changed from hours to seconds by knowing that 1 hour is equal to 3,600 seconds. So our hours cancel, and we're left with seconds. So then we're going to divide 65 times 5,280. We're going to divide that by 3,600. And that gives us 95. So 95 feet per second. Now we're going to take that number down here, and we're going to multiply it by one more conversion factor. So we know that there's 3.28 feet is equal to 1 meter. So if we write this as a fraction, this is really just 1. So we're just multiplying our answer by 1 again. So we're not changing the actual value. So if you multiply 95 times 1 divided by 3.281, you get 29. So here our feet we put on the bottom so that they cancel out with our feet here, which were on the top. And now we're left with meters on top and seconds on the bottom. 29 meters per second. So we've successfully converted from miles per hour into meters per second. Okay, this technique in general is called dimensional analysis. So dimensional analysis can be used, in this example, they're showing how you can substitute in a symbol for a quantity into an equation to see if the equation is valid. So this is one method that you can use to check to see if an equation will work. So a lot of times in this class you're going to be using an equation that you might not have written down right in front of you. For the multiple choice section of the AP test, you are not allowed to use your equation sheet. So this might be a useful skill to help you figure out whether the equation you're using even makes sense. So in this case, we see that we have an equation x equals 1/2 times v times t squared. Now x stands for distance or length, so we're putting in an L for length. And then we don't need to put in this 1/2 because that's just a number. There's no quantity associated with that, so that's not going to affect the dimensions that we're dealing with. But v, speed or velocity, that is a length divided by a time. Length over time is velocity, or distance over time. And then here t stands for time. So we're going to use t, and that gets squared. So if we simplify this t squared here, one of these t's cancels out with this t on the bottom. So then we wind up with L equals L times t. So length equals a length times a time. What? That doesn't work. So that means that this equation that we started out with is invalid. Now I personally like to use this method using the units for these quantities instead of just using L's and T's and whatnot. So what we could have put in instead of x is m for meters, because x is a distance measured in meters. And then in place of v, we have meters per second. That's the units that we use for speed in the SI system. And then we had time squared, so that would be seconds squared. So again, we see that our seconds squared here, one of these cancels out with the seconds on the bottom. We wind up with meters is equal to meters times seconds. Again, this does not make sense. So we know that the original equation we started out with is not valid. So let's try this one. Suppose we have x equals v times t. So let's use our units method again. So our x was going to be in meters. That's our distance. Our speed was in meters per second, and our time, t, was in seconds. So this was our x, this was our v, and this was our t. So now this s cancels out with this s, and both of them go away. We wind up with meters is equal to meters. And the world is happy again. Meters equal meters. So that means that this equation is dimensionally correct. This could make sense. Okay, we're going to stop there for now and continue the rest of this chapter in the next video.